Hello everyone, and thank you for joining me. So today I decided to talk about IPv6. Now, I don't want to spend too much time talking about how to subnet IPv6, but rather I'd like to take a more deep dive into the different IPv6 unicast addresses. So this video is not so much on how to subnet an IPv6 address, but more what can the IPv6 unicast addresses do or what they can't do. And ultimately, the goal is to have these two PCs be able to reach each other from different geographical locations. So today's video is called Understanding IPv6 Routing. I hope you enjoy. All right, let's get to it. So before we do a deep dive into the command line of IPv6, I want to do a quick review of the different unicast addresses that we'll be working with. Then I want to spend about a minute talking about the IP version 6 128-bit addressing scheme. Now, the reason is because when we do begin configuring our IP version 6 network in GNS3, we need to make sense of what is actually going on, and it'll help us a lot during the troubleshooting phase as well. So I'd like to start off with the link local. So the link local address is essentially used between devices on the same link. I would also go to the extent of saying subnet, and I can prove that to you. So the second thing is not routable. These IP version 6 addresses that we're about to see cannot escape the subnet that they pertain to. They're isolated and constrained within the subnet that they are participating in. Very important. Usually, they also start with the address of FE, and we'll see that when we go through the configuration. The unique local is identical or used for the same purpose of private addressing in IP version 4, okay? In IP version 4, used for the exact same purpose. Usually you'll see them as FD, right? So if you see an FD, it's a unique local. If it's an FE, it's a link local, okay? And let's try not to get mixed up here. And these are routable. These addresses are routable within the autonomous system they pertain to. Okay, and we're going to prove that. So having done this, we'll go to the last one, which is the global unicast. The global unicast serves the exact same purpose as the public address space in IP version 4. So used for the same purpose of public addressing in IPv4. If you see the 2001 00/64, you know that it's a routable and global unicast address. So these addresses can be routed over the internet, which means that if IP version 4 did not exist and we were living in a world of IP version 6, these are the IP addresses that would essentially be used for applications to speak to each other, okay? So for example, if I wanted to reach a web server in another part of the country, I would need a global unicast address that would be permitted to be routed over the internet to reach that web server. So they're very important. Okay, so this is a nice little quick review. Hope you enjoyed it. Let's get on. All right, everyone. Now, before we get into the command line, I just want to talk a little bit about the IP address structure of IP version 6. Okay, the addressing structure. So, as you know, IP version 6, the address space is made up of 128 bits as highlighted here. Now, I've broken down each hex text into their respective column. So this is hex text 1, hex text 2, hex text 3, and hex text 4. Now, I like to also call these segments. So please forgive me in the video if you hear me say segment 1, segment 2, segment 3, segment 4. It rolls off the tongue a little bit easier. And that's just, I've just, for whatever reason, came accustomed to saying that. So moving along, the first 4 segments of the IP version 6 addressing structure identifies the network ID. The last four segments of the IPv6 address structure refer to the host. Now, there are two important segments in my view that you're going to need to pay attention to. That's segment 1, hex text 1, and hex text 4. All right? And the reason is because hex text 1 will allow us to identify which IPv6 unicast address we're dealing with. And having said that, we'll be able to identify the characteristics that are accompanied with that IPv6 unicast address. So for example, this is a unique local. We know that because it has FD in front of it. We also know now that it is routable, but within its autonomous system. And we also know that it's equivalent to the IPv4 private address space, right? And that's what I mean by segment 1 being important, because we've moved to the second one. As long as we see 2000, if we see 2000 here, then we know it's a global unicast address space. All right. If we move to the third one, we know it's a link local address space, and we're able to tie it back into its characteristics of what it can or cannot do. All right. Now, the fourth segment is, in my opinion, the most important. And here's where you're going to be sidering. Okay. Here's where you'll be able to carve up your IPv6 address space into smaller parts for use of a particular business unit or even a business case. So as you can see in this little example here, I've decided to use all four segments of the first part of the IPv6 address space. Okay, so having said that, I'm using a /64. All right, now what does that mean? What that means is that with this unique local IP address space, my subnet is 0, because this last bit is always off. It's not on, which means that if I go to my IPv6 CIDR calculator, you can see that the first 4 segments of the IPv6 address space do not change. That is my subnet, because I'm using all 64 bits. However, I can have from 000 to a broadcast of Fs, and the total number of hosts in that subnet is, and I'm not even going to try and say that number because it's just astronomical, but I'm hoping that you do get the point. Now, let's just say that we exhaust the number of hosts on this subnet, and we're forced to expand this IPv6 address space to suit our needs. Well, at that point, we would change it to a /63, all right? And what we're effectively doing is we're trying to say we want the last bit to be either turned on or off, which means that the last hex decimal value can either be a 0 or can be a 1. It can be a 0 or it can be a 1. Those are my two subnets, right? Because the /63 breaks down into two /64s. Sound familiar? So let's go back. Now, if I decide to change this guy to a /63 on my IPv6 CIDR calculator, you can see that my subnet has now changed from the bit to being turned on to 0, off for 0, and to being turned on for subnet 0 and subnet 1. And my number of hosts have now doubled, and so forth. So now I'm hoping that you can take this principle of what I just showed you and apply it to your everyday needs. Thank you for watching.